new material, stuff that wasn't covered in class. The meat of it, though, is going to be in the video that I'll show afterwards. And I brought along one of my co-stars to join us. So yeah, so my general subject was like protein degradation, so we talked about that in class. So hopefully you guys are just familiar with this pathway. It's pretty simple, really. So for the purine degradation, so the first step, we use the nucleotides. We get rid of the phosphate group, then we get rid of the nitrogen, and then from that point, really it's just about. Then we get rid of the ribose, and then we use the xanthine oxidase is used twice, and really it's just adding a double bonded oxygen onto the purine. Then when it gets to the second double bonded oxygen, that creates uric acid, which then is commonly, that's the one that's like excreted out of the body. It can also be urate depending on the pH. But that's like our pathway. So the big key players here, the xanthine oxidase is really important. That's one you're going to remember. Particularly it's xanthine oxidase. When it goes with xanthine, that's what creates the uric acid. So, just like going through the research, so there's multiple purine degradation diseases, and they're basically all in just, there's two ways they happen. Either it's an overproduction or underproduction of the purine degradation, so too much uric acid, not enough uric acid. So that's where here you can see it's either block the degradation or increased degradation, kind of going back to the hypo versus hyper degradation. Really all the purine degradation diseases come down to that. So some research, when I was doing some research, I found it interesting that the purine degradation pathway, so it's a major biochemical source for reactive oxygen species. There's like double bonded oxygens that we put on it. And so at sites where there's like gingivitis or periodontitis, we noted the research saw that the purine degradation was really accelerated at these sites. And so I just thought that was interesting, that like even just in our teeth, this purine degradation is going on. This one is really interesting. So they're looking at purine degradation and cancer. So it's perhaps that purine metabolism may fuel cancer progression. And so they're looking at the needs from the purines. And so what they're like starting to do, this is pretty recent, I believe, but they're looking for purine metabolism. It's one of the targets for potential treatment of cancer. And then, so yeah, so purines are important for the building blocks of DNA, RNA, and then, so what I thought was interesting, so the purine metabolites provide a cell with the necessary energy and cofactors to promote cell survival and proliferation. Proliferation is like the rapid repeating of like the cell, and it just like multiplies itself. That's kind of like what cancer is, so it's definitely like related there. And then, so this was just saying that basically, yeah, there's a lot of research going on with purine degradation. They've uncovered a lot of diseases, and they're still doing more. Yeah, they're basically just looking at this quite a bit. And then, so the video I'm gonna like, it's a skit I performed basically. It's kind of over gout, which is known as King's disease. That's because it's associated with the high intake of like beer and then red meat, if you guys remember from class. So what gout is, it's a buildup of uric acid around the joints, so it's an overproduction of the degradation pathway, so too much uric acid is being produced. So xanthine oxidase is the key enzyme. It catalyzes the final two steps in that pathway, like I talked about earlier. And then to relieve the symptoms, what's commonly used is allopurinol, which is a suicide inhibitor. So that's going to irreversibly bind with xanthine. So therefore, xanthine oxidase can't bind with this. So therefore, no more uric acid will be produced. And that can relieve the symptoms of gout. And then here are the references they used. Oh, I get to the.
Action. of the King John of Wienerville.
Woo!
Your beverage, good sir.
Let's break.
Oh wait, am I supposed to go right now?
Thank you.
Here's your fresh fuel, sir. It's a little undercooked to me. Man, my foot has been killing. Let's take a look at that. Why don't you take off your socks so we can get a better view?
Oh.
My goodness, do you see that? That's like a really suckable toe. I mean, that's a little nasty looking. You know, I think you should probably take some allopurinol. You're not a doctor. Well, no, but I've taken 2 semesters of biochem with Dr. Mariah Beck, so I'm the best thing you got. I think I'm gonna be bonded with xanthine oxidase. Oxidase. I think I'm gonna be bonded with Anthony at the end of the night. I'm just cables, but I'm gonna be bonded with Willow tonight. I'm gonna bond with these cables. I'm allopurinol. I wasn't invited. But I promise you, I'm gonna be bonding with Anthony. Uric acid. Anthony's mine.
Sorry.
Looks like that allopurinol did the trick. Now nobody's gonna want to suck on these toes. Except me. Here's your fresh deal, sir. Oh, yes,
Can't train a bird.
Eat it! Eat it!
So that was it.
Okay. No animals were harmed in the film.
Submit that to bar school.